So this is experiment 1. I'm going to walk you through the experiment and give you data as we go. You should be filling out this report sheet. This is in your lab manual. So we're going to be putting our numbers in here. You may have to pause as I go through things to take down some measurements and stuff. The first part of the experiment, you're supposed to measure a dollar bill, but I didn't have one, so I just measured this piece of paper, essentially. And that's pretty hard to see, so I'm going to scan in. We're going to do the length and width of this. This is on your report sheet. This is number 1. This first is the width. And I know it's not, you may have to pause it, it's not totally clear, but that's how it is in real life. It looks like the corner of my paper is crinkled a little. Remember that when you record these, you need to record a line for every, a digit for every line. In other words, each of these lines is the 0.1. So you have a line for those digits, which means you need to estimate this one. Estimate between the lines. So go ahead and make your measurement. That's the width. And then this one is the length. Okay, and you should, to figure out what to do on the report sheet, you probably need to go back and look at the procedure that comes with this experiment. But if you do, you'll see that all of this is calculations. We just recorded these two, and so you'll have to do calculations for those, and it tells you about that in your procedure. So you should refer to your procedure to see what's going on. Okay, next we're going to look at volume measurements. And, you know, beakers and flasks are not the ideal way to take a volume. So we're going to kind of do a thing to see how good or bad these do. So what we did was we filled up a beaker and a flask to what looked like 40 milliliters in each one. And then to see how much there really was, I took that 40 milliliters in the beaker and poured it into a graduated cylinder, which is a better way to determine the volume. So when I did that with the, let's see, this one is the beaker, and this one has the flask water. So you can see how much they really have. On these, let's just talk about sig figs. On these, there's a line for like the 40, and there's a line for every one. So there's lines for those two, but you need to estimate one digit between lines. And you may need to refer to your notes. This is, this is how a meniscus looks in real life. It's not always as clear and sharp. When it falls kind of near a line, it's a little bit harder to see. So anyway, you need to know like where in there you take that measurement. Your percent error, what you're reading off here is the measured numbers. And what it says in the formula for actual, that's the same thing as expected. And for us, use the 40, like so. Okay, moving on to the mass part. First, we're measuring the mass of a coin, and I did a nickel. And this is what the scale said. You should know what to write down for that, how many digits to write. Then next, I'm going to use these 2 flasks. And I think I changed the size on this. It may not be updated in your manual, but 250 milliliter flasks, both of them. Notice that it's a 250 milliliter flask, but the scale over here only goes up to 225. Theoretically, up to the very top would be about 250. But as you know, a flask like this is not meant for volume. But anyway, these are both 250 milliliters. And see if it might be good to kind of notice if they really look the same. And I'm going to number these. This is 1 and this is 2. In case you need to go back and look at them. So this one is 1 and this one is 2. But anyway, I put them both on the scale and you should be recording those 2 masses. Last, we're going to do temperature. I put this thermometer in a ring stand, but really, as long as nothing's touching this bulb at the end, you're going to get a reading. So I did it over here. Make sure you're writing the correct number of digits according to the lines that are shown or the line that is shown. So this is room temperature. And that's a reasonable temperature, around 20. Oh, and of course, this is in Celsius. An ice bath, looks like that's discontinuous. So an ice bath is where you fill a beaker with ice, and then you add water to kind of fill in the space, and you mix it up. Now, you may think that an ice bath is going to be, or you may think that ice is always at 0 degrees Celsius, and it's not. When you get it out of the freezer, it's less than that. But when you put it in water and mix it up, the ice will warm until it gets to 0 degrees. The melting / freezing point, it's the same temperature. Celsius is based on freezing point of water. And when it gets to 0, the ice starts melting, and it'll stay at 0 until it's all melted. So of course it's not perfect. This is our reading, and so it's not right on 0. Be sure to write down the proper number of digits for that. Here's our boiling water bath, and when you make a boiling water bath, we use a boiling chip. The function of that is that it provides a surface where the bubbles will form on it, so that it doesn't get superheated. Sometimes it's like seeding crystals. It needs something to help get started. You've maybe noticed the same thing as a boiling chip if you're heating up water for spaghetti, and you heat it up pretty good, and maybe there's a few little bubbles forming, but then you put the spaghetti in, and the spaghetti gives it a rough surface where the bubbles can form easily, and it bubbles like crazy, a lot of bubbling. So the boiling chip kind of keeps that from happening. It allows it to start bubbling right away. Anyway, so this is how you make a boiling water bath. To take a temperature, you don't want the thermometer touching it. Anyway, and again, here's the temperature. Theoretically, at 1 atmosphere, this should be 100, but it's not exactly. And so write down what that is with the proper number of digits. And that's it. Now you have all the data you need to do your lab report. Be sure to answer all the post-lab questions as well.